butadiene, and when this goes into ring closure process, what happens? This pi bond move to, in this direction, and this pi bond move in this direction, forming a sigma bond here and a pi bond here. That means one sigma bond has been formed at the compensation of one pi bond. Here we had two pi bonds. In this we have one pi bond and one new sigma bond. Similarly, this is a ring opening process. In this we have cyclohexadiene. During the ring opening process, this sigma bond will move towards this pi bond will move toward this pi bond will move toward this, forming one pi bond, and we will get our cyclohexatriene, a ring during ring opening process. Thus here, because this is ring closure process, ring opening process, so we have one pi bond extra and one sigma bond is lost. Now so we can say that during electrocyclic closure of the ring, the cyclic partner has one pi bond less than the open chain partner. That is, it has 2 pi electrons less than the open chain partner. It is very simple concept, not too much to worry. Now we should know the important characteristics of electrocyclic reactions. So first, very important characteristic of electrocyclic reaction is that all the electrocyclic reactions, that means whether it is ring closure or ring opening, is always purely stereoselective reaction. It is very important to remember. It is a type of stereoselective reaction. Now what is stereoselective reaction? Stereoselective means selection of only one stereoisomer among the various possible stereoisomers. That means if there is possibility of formation of various stereoisomers, then in that case only one particular stereoisomer will be formed by a particular product. Got it? And second very important characteristic is that all the electrocyclic reactions are stereospecific as well. So we can say that all the electrocyclic reactions are stereoselective and stereospecific. What is difference little bit between stereoselective and stereospecific is that stereoselective reactions में क्या होता है, सिलेक्शन होता है कि आप इतने बन सकते हैं, लेकिन वो पर्टिकुलर एक ही आइसोमर को बनाएगा एक रिएक्टेंट. यहाँ पर क्या है स्टीरियोस्पेसिफिक में कि अगर एक रिएक्टेंट, मान लीजिए आपका एक रिएक्टेंट से प्रोडक्ट हमें बन रहा है, डी आइसोमर बन रहा है, तो उसका अगर जस्ट अपोजिट जो रिएक्टेंट होगा, अपोजिट आइसोमर, वो जस्ट अपोजिट प्रोडक्ट देगा. यहाँ पर क्या होता है कि वन गिवन आइसोमर गिव्स वन प्रोडक्ट, whereas the another isomer will always give the opposite product to that of. Now what is stereochemical outcome of the product depends on the way of opening of the ring or closure of the ring. This is very important to remember, and I will explain you later very clearly that which type of stereoisomer we will get. It depends upon the way or mode or motion of the movement of in which the ring is getting opened or ring is getting closed. So there is two possible ways of motion of orbitals. Actually what happens, whenever ring is formed or ring is getting opened, there is movement of movement of orbitals. When we are going to open the ring, if this is a sigma bond and this is our complete ring, and this is a sigma bond formed by the overlapping of two orbitals, and we to open up the ring, this sigma bond will get broken up by the opening of these two orbitals, will get opened up in this way. So if the two orbitals just move in the same direction, like these are two orbitals, these are two orbitals, and if these two orbitals move in the same direction, whether clockwise or anti-clockwise, then this type of movement or motion is known as कॉन्ट्रोटेटरी. मतलब होता है एक साथ एक दिशा में ओपन होना या मूव करना. और दूसरी पॉसिबिलिटी क्या है कि हम जैसे यहाँ पर है कि ये कॉन्ट्रोटेटरी मोशन कैसा होगा कि ये ऑर्बिटल आपका इस तरीके से मूव कर रहा है, यानी कि क्लॉकवाइज मूव कर रहा है, तो ये वाला जो ऑर्बिटल है वो भी आपका इस तरीके से मूव करेगा. I think you all must be getting this, that this is two orbitals by which we have a sigma bond. So this orbital is getting opening in this way, clockwise opening. So the lower orbital will always move in the clockwise direction in this way. So this is the movement in conrotatory motion. And the another possibility is that the two orbitals by which a sigma bond has been formed may rotate or may move in opposite direction. That means simple, if one orbital is rotating in clockwise direction, the second orbital will open up in the anti-clockwise direction. That means in this way. So this is rotatory motion, and this is conrotatory motion. This is conrotatory motion, and this is simple disrotatory motion. Later you will get it very clear. Now another characteristic is that whether during an electrocyclic reaction it will be a conrotatory motion or whether there will be a disrotatory motion depends completely on the number of pi bonds and on the presence of light or heat. If a particular molecule is undergoing in conrotatory manner in presence of light, then in presence of heat it will always go in disrotatory motion, just opposite. अगर वो heat की presence में उसमें conrotation हो रहा है, तो लाइट की प्रेजेंस में हमेशा ही उसमें डिसरोटेशन होगा, कॉनरोटेशन नहीं होगा. सिमिलरली conrotatory motion and disrotatory motion in which way that particular ring will open up or it will close depends upon the number of pi bonds. And how it depends upon the number of pi bonds we will explain in just the upcoming video, which will be just I will be uploading within half an hour. So I hope you all must be getting it clear. You all must be able to imagine all these things, because pericyclic reactions you can't understand without any imagination. So I'm again emphasizing you all just to imagine the things. I hope you must be getting. If you have any doubt, just let me know. I will try to do my best. Thank you.